A 21 million parameter open model, built by an academic team at Cambridge, just outmapped Google DeepMind's flagship Earth model. It's called TESSERA v2, and how they got there is stranger than the result. TESSERA's unit isn't a satellite tile. It's a single 10-meter pixel. It takes a full year of radar and optical observations and squeezes them into one frozen vector you can probe for any map. Across 395 controlled runs, on 1,000 GH200 chips, pretraining loss barely predicted downstream skill. The correlation was negative 0.18. Chasing a lower loss can cost about 2.5 times more compute for the same result, so they built the scaling law around downstream performance instead. On the full 29-task benchmark, the 21 million parameter model scores 0.611, the best composite of any system they tested, ahead of TESSERA v1, AlphaEarth, and OlmoEarth. And on AlphaEarth's own 15 tasks, it still wins 0.581 to 0.56. How does a model this small compete? They distill a 1 billion parameter teacher into nested embeddings. The first 16 numbers alone keep about 92% of the full score, at 1/8 the storage. The naive version fails. Distilling against a fixed teacher supplies the ordering. 3 honest caveats. The V2 weights aren't out yet. The team says V2 lands soon, but today you can only grab version 1. The scores come from the paper's own protocol, not a rerun of Google's internal tests. And this is satellite radar and optical only. Nothing here transfers to general vision. The paper's on ARG of today, and the code is MIT licensed. Version 1's embeddings are already free through GeoTessera, and the V2 weights land at the same repo when they're ready. The lesson underneath the maps: optimize for the task you actually care about, not the number that's easy to watch. That's how 21 million parameters caught a Google flagship.